Hello, in this video I'm going to look at numerical integration using the Simpsons rule. So Simpsons rule is essentially a method of numerical integration that pretty much uses parabolic functions, meaning that if we were to integrate something that is of a parabolic form, then it's going to be most accurate in that sense, which means that for anything such as like linear and constants, that it's going to be very accurate for those types of functions. But in either case, we can just look at some examples of using Simpsons rule. Now, Simpsons rule essentially is a formula of which we have written down here, but we just need to write some details such as b minus a over n. This is equal to our delta x. So what that means is that essentially you can kind of rewrite the formula if you want to, but you really don't have to. The other thing of which that we can look at is, for example, I know that if I were to use an even number of intervals for my trapezoid sum, basically this is equal to the average of the trapezoid sum with n subintervals and the midpoint sum with n intervals. But furthermore, I can actually use another formula that we have that says that if my intervals were even for the Simpsons rule, basically that's going to be 4/3 times the 2t sub 2n minus 1/3 t sub n. Now, if we were to, say for example, substitute this formula in, basically we would get the following if we substitute, if we're going to go ahead and substitute the numerical stuff right here. So we have let's write it like this. We have 4/3 multiplied by t sub n plus mn divided by 2 minus 1/3 t sub n. Now what this does is it gives us a nice little formula in terms of the midpoint and the trapezoid sum. So we have 2/3 mn plus 1/3 t sub n. And this is only valid for n greater than or equal to 1. So that kind of gives us a kind of like this idea that if we happen to be estimating a function, y equals to fx, that means that potentially, because of the fact that the trapezoid sum is actually the average of the left and the right. That means that in a way that if you were estimating the area beneath a function from a to b, you could probably just make a diagram or a chart where you have the left sum, the right sum, you have the trapezoid sum, but then you also have the midpoint sum, and then furthermore you have Simpson's rule, which that says s sub 2n. Okay, and that would be kind of interesting if we can formulate like a table with respect to using Simpson's rule. Now the other thing of which that we can kind of mention as it relates to Simpson's rule is, for example, how to find the error. Well, the error, which we can denote as the absolute value of e sub s to denote the error, is going to be the maximum times b minus a to the 5th power divided by 180 n to the 4th power. Now in this case, the maximum for your derivative is actually the 4th derivative of of x. Yeah, it's the 4th derivative, and we're just going to call that the maximum. Now keep in mind that this is with respect to still the integral from a to b, and that, this is kind of determining what size n you would need in order to be within close proximity of a bound, for example. So, we can actually use that to our advantage for some questions for uh, other items. So, like estimating, I don't know, like natural log of 2, for example, that could be 1, for instance. But let's go ahead and look at an example where we take a function. So we're integrating from 0 to 4, and we have 4x cubed plus 4x plus 3. Okay, and this is going to be dx. Now here, we're going to use that n is equal to 4, which means that delta x is equal to 1, meaning that we have a partition that says 1, not 1, but 0. So we have 0, 1, 2, 3, and 4. And we just want to find those. But let me do it like this before I even, plug in my formula for Simpsons Rule. So I know that I need to find f of 0. So f of x is equal to 4x cubed plus 4x plus 3. Now, f of 0, though, is just 3, right? Okay. F of 1, well, what is f of 1? F of 1 is essentially 4 times 1 cubed plus 4 times 1 plus 3. So that's going to be 11. Okay. F of 2, well, what is f of 2? You have 4 times 2 cubed plus 4 times 2 plus 3. So this is going to be 8 times 4 is 32, plus 8, which is 40, plus 3, so 43. Okay. Yeah. 2, 8, 11, 32. Okay, so 43. Next we have f of 3, and that's going to be 4 times 3 times 3 cubed, okay, plus 4 times 3 plus 3. And that's going to be, okay, so 27 times 4. Let's see, 27 times 4, 108. Okay, so we have 108 plus 12 plus 3. So basically this is going to be 123. Yeah, because you have 123. So, right, we need one more actually, and that's f of 4. So we have 4 times 4 cubed plus 4 times 4 plus 3. Okay, this is 16, so that's plus 3, that's 19. 4 to the 4 is, let's see, 4 to the 4 is, I think it's 256, yeah. Plus 16, and then plus 3. So you get 275. Okay, so we can probably plug in everything now for our Simpsons rule. Now, Simpsons rule basically says that you're going to take, let's see, the formula says delta x over 3. Okay. But what was delta x? It's just 1. So really, it's going to be 1/3. Okay, so we have 3. Okay, 3 plus 4 times 11 plus 2 times 43 plus 4 times 123, and then let's see, plus 275. Okay, so we have plus 275, and we just need to find what that's going to be. Okay, so go ahead and plug this into your calculator, but in either case, when you plug this into your calculator, whether you're going to plug in the whole thing or just take 3 plus 44 plus 86 plus, that should be 2105. Yeah, what is 123 times 4, 492. Okay, so we have 492 and then plus 275. Either way, if you add up all of this, you get 900 divided by 3, which is 300 squared units, actually. So notice this. Okay, so we use Simpson's rule, essentially. But notice this. If we were to go ahead and just integrate the original function from 0 to 4 of 4x cubed plus 4x plus 3, notice that you end up getting x to the 4th plus 2x squared plus 3x, and this is from 0 to 4. Now, basically that gives you 4 to the 4th plus, well, 4 squared is 16, that's 32, so plus 32, plus 12. Okay, so I know that this is 44, but this is 256. So 256 plus 44, that equals to 300. So we find that basically that the error for this particular example is actually equal to 0. Okay, so that's actually pretty interesting in either case because it avoided really having to find the antiderivative, but finding the antiderivative, it actually happened to not be as bad as we think it might have been. But check this out. Okay, so what if you had a question? Okay, so what if you had a question of which that you wanted to find the surface area generated by the function y equals to 2x squared, and this was from 0 to 3. So surface area is found by taking the integral from a to b of 2 pi f of x multiplied by the square root of 1 plus f prime squared dx. Okay, so in that case, that means that basically you have the following function. You have the derivative is equal to 4x, but what's the derivative squared? It's equal to actually 16x squared. And then from there, you're going to basically plug in that the surface area from 0 to 3, and you're going to get 2 pi multiplied by, well, you have 2x squared, then you have the square root of 16x squared plus 1 dx. Okay, now, of course, if you were to change that, like let's say that you go ahead and change this into the integral from 0 to 3 of 4 pi x squared, and then you have the square root of 16x squared plus 1 dx. Well, now it becomes a question as to how are you going to find this integral, and know that it's really just looking for a numerical approximation in reality. So that's going to be pretty challenging actually to find the antiderivative. I mean, it's not impossible, but we can, avoid it by using numerical approximations. So let's say that, for example, that you want to use Simpson's rule where you use 6 intervals. So if you're going to use 6 intervals, then in that case, you know that delta x is equal to 3 divided by 6, which means that it's equal to a half. So from there, we go ahead and we plug in our formula, or we look at our partition in actuality. What is the partition? The partition is 0, 1 half, 1, 3 halves, and then 2, and then you have 5 halves, and then you have 3. Okay, now the question furthermore becomes, okay, well, we still technically need to plug in everything, right? Everything into the formula. So how would we find that? Well, okay, so what you would probably need to do is to look at, like what happens when you plug in the 3 and the 0 and such. So let's go ahead and set this up. So I have that S6 is equal to, okay, so essentially you have delta x over 3, which means that in actuality you're multiplying by a sixth. Okay, now the other part of this is that, one way that you could do this is just have everything multiplied by 4 pi, by the way, because the 4 pi is just a constant. But in either case, let's just not even think of that for now, because we still need to do f of 0 plus 4 times f of 1 half plus 2 times f of 1 plus, okay, 4 times f of 3 halves plus 2 times f of 2, and then finally plus 4 times f of 5 halves, and then plus f of 3. Okay, so ran out of room a little bit, but here is the approximation, or the math that you'll need to do for this one. Now, in either case, when you plug in 0, you know that you're going to get 0, okay? Now, if you happen to look at f of 1 half, though, what is f of 1 half? F of 1 half is 4 pi times 1 half squared times the square root of 16 times 1 half squared plus 1. And basically that's going to give you 5. So it's going to give you pi times root 5. Okay? So I have my f of 1 half. Okay? But notice that you need to multiply by 4 pi, right? Okay, or 4. And it's up to you, like how you want to interpret it. Furthermore, if you go ahead and you find, let's say for example, f of 1, okay? So f of 1 is going to be 4 pi times 1 squared times the square root of 17. Okay, so in that case, we have that that's just going to be times 4. But let's see. Yeah, but yeah, we have that that's actually going to be 4 pi times the square root of 17 in either case. Okay, and let's go ahead and just try one more. Let's try 3 halves. So if we go ahead and we try 3 halves, remember that that's going to be 4 pi times, okay, so you have 9, because remember that the value is getting squared, so it's 9 over 4. And then you have that that's going to be 16 times 3 halves squared plus 1. So here that gives you 4, so that gives you 4, so that's 12. Let's see, 12 times 3 is 36. Okay, so that gives you right, it gives you 9, and then the square root of 37. Actually 37, right? Yeah, 37. And there's a pi there. Okay, so you can see that basically the pi is a constant in reality, and that you're going to multiply everything by 1/6 after you finish. Okay, so in either case, once you do the computation, once you get, the remaining, because you still need to do f of 2, you need to find f of 5 halves, and then you need to find f of 3. But once you plug that in, basically you're going to find that s of 6 is approximately 10, okay, 1024.885. But notice that this would be in units squared because the original problem started with finding the surface area that's generated by this function rotated with respect to the x-axis. That's just one thing that I might have omitted, that this is supposed to be, find the surface area about the x-axis. Okay, but we would have gotten that from here anyways, because this is the formula, respectively. That's the formula for rotating about the x-axis.